Loops are a set of instructions or a block of code that will continually be repeated until a condition is met. All loops must contain 4 conditions for them to work properly. You need to initialize some loop variable, you need to have a loop condition to determine when to keep looping and when to stop looping, you need a loop body, which is the code that executes in each iteration of the loop, and you need to update your loop variable. This is a basic diagram of how a loop works. You start in the top left at the loop variable initialization. You then check the loop condition. If it's true, it will enter the loop body, and then it will update the loop variable, and then will check the loop condition once again. It will continue this blue loop until the loop condition evaluates to false, where it will continue with the rest of the code. Let's take a simple example of counting from 1 to 10. Without loops, this is what your code might look like. It looks very repetitive and messy. This is a prime example of what you should use a loop for. The first type of loop I want to introduce is the for loop. For loops are defined by the for keyword. After the for keyword, we have a set of parentheses with 3 statements inside. The first initializes our loop control variable, the second is the condition that is checked to see if the loop continues, and the third is updating the loop variable. At the end of each loop, it will automatically update the variable based on how you defined it here. Then there are a set of curly braces which define what the body of your loop is. Everything in between the curly braces will be the code block that continues to loop until the condition is met. Let's take the same example as before with counting from 1 to 10. Here's what the code would look like in Java, but other languages will have similar structure with only slightly different syntax. Here we initialize a loop variable. This is the variable that will be compared to check if the loop should continue or not. We initialize it to 1 because we want to count starting from 1 to 10. Here we have the loop condition. This code will continue to loop as long as I is less than or equal to 10. Inside the curly braces we have our loop block. Here we simply print out the loop control variable. Finally, at the end of each loop, the loop control variable is updated to get it closer to the condition. Here's what the same code looks like in diagram form. Notice how the structure is very similar to the general loop diagram. Before our initial iteration of the loop, the variable I is initialized to 1. On the first iteration, the condition is checked and evaluates to true, so the print statement executes and then I is updated to 2. Then it enters the loop again on iteration 2 and the condition is checked again, and the loop continues. Then the loop is checked with 3 and 4 and 5 and so on and so forth. On iteration 10, the I variable will be updated to 11. Then the condition is checked, 11 is less than or equal to 10, which of course is false, which ends the loop and continues to the code after the loop block. The next type of loop is the while loop. The while loop is a lot more universal than the for loop and looks much simpler. You start by initializing the loop variable outside of the loop block. Then you have the keyword while with the parentheses containing the condition. Then you have the curly braces which define the loop body. Then inside the loop body, you must update your condition variable manually. Unlike the for loop, while loops update the condition variable inside their loop body. Let's look again at counting from 1 to 10, but instead with while loops. Here's the Java code. Here, we initialize the loop control variable outside of the loop. This time we call it counter. Then we have our loop condition, which is the same as our for loop. It checks if the counter is less than or equal to 10. We have our loop body which will print out the count variable, and then we have our counter variable updated inside of the loop body. So why would you use a for loop versus a while loop? The general rule of thumb is that you should use for loops for times when you know how many iterations you need. Think when you are looping through something with a definite size. A while loop can technically be used for any kind of loop. But since for loops are much better for loops of fixed size, we typically use while loops when we don't know how many iterations are needed. There are many other types of loops which I won't really be covering, but they are essentially just other implementations of the loop. There is the enhanced for loop, also known as the for each loop. This loop is very good at looping through data structures and other objects. There is also the do while loop, which is very similar to the while loop, but instead executes the loop body once before checking the condition. This guarantees that the loop body runs at least once. Now let's consider the case of an infinite loop. This code from a first glance seems to be a normal while loop. Let's check to see if it meets all the conditions for a loop. It initializes a loop variable, it has a condition that will stop the loop, it has a loop body, and it updates the loop variable. So what is the problem? Why will this code continually loop? Well, the problem actually has to do with how this loop variable is updated. If you notice, the loop variable is decreased on every iteration, therefore the variable will always be less than or equal to 10, so it will in theory make an infinite loop. This is why you must be very careful with loops such as the while and do while loop. Since you manually update the loop variable, you have to make sure that your loop variable will eventually reach the case where the condition evaluates to true and the loop is ended. If that isn't the case, you just created an infinite loop. And that's all you need to know to understand the very basics of loops. If you enjoyed it, feel free to like and subscribe. Thank you for watching.